In this chapter, reactions in aqueous solutions will be introduced, and I'm going to review just some general properties and ideas surrounding these aqueous solutions here. So, in general, the definition of an aqueous solution is whenever we have water as the solvent. So, aqua is another language terminology for water, so we can see where this name comes from. So solutions in general, now they don't have to be liquid phase, but a solution is a homogeneous mixture of two or more pure substances. And I've mentioned in previous lectures that a solution can be liquid, gas, like our air that we breathe is a homogeneous mixture of gases. But specifically in this chapter, we're going to talk about water as a solvent with either another liquid or solids dissolved. And when we talk about solvent, that's going to be the part of the mixture that is present in a greater amount. So you can have 100 grams of water if we have an aqueous solution, and then if we could dissolve 99 grams of something else in water, so maybe another liquid, water would still be the solvent because it's present in a greater amount. The solute is simply whatever is present in a lesser amount. So generally that will be a solid or another liquid that's dissolved in our aqueous solution. So when we talk about a liquid solution, we have one over here. So methanol, these molecules with the black balls here, these have carbon in them. And then these here that I'll box in, these are water. So notice that water is the solvent present in a greater amount, and then we have methanol is our solute. So there's a liquid solution, an aqueous solution right there. And then what we might more commonly think about would be an ionic compound like sodium chloride making a salt solution here. So I boxed in NaCl, that's the molecular formula, the ionic formula actually here for sodium chloride crystals. And I talked about in a previous lecture how they are solvated, so surrounding here with water molecules, we have the chloride ion. So these ionic salts, these ionic compounds will do what's called dissociation, or not only do they dissolve in water in aqueous solution, but the solvent will pull the individual ions from the crystal as it solvates them. So that's what we see here. Here's our chloride, and then the sodium ions here are solvated by water once again. And the terminology here, electrolyte, is any substance that will dissociate into ions when dissolved in water. So we could say sodium chloride is an electrolyte. It will dissolve or dissociate specifically into ions when dissolved in water. And then we have things like methanol above or other non-electrolytes like glucose. They're molecular compounds, not ionic compounds, and they tend to only dissolve but not dissociate into ions. So we could see glucose or sucrose, table sugar, either will dissolve in aqueous solution, they would dissolve in water, but they won't ionize. They won't turn into carbon or hydrogen or oxygen ions. They'll stay as molecules. So that brings us to this comparison here, where I mentioned above that soluble ionic compounds tend to be electrolytes. So we can see that all ionic compounds mentioned here will be strong electrolytes. No ionic compounds are classified as weak electrolytes or non-electrolytes. Then we see that we have molecular compounds. So that's all nonmetals bonded together like methanol, glucose, or sucrose. There's strong acids listed. We'll discuss what a strong acid is. They are all molecular compounds. So things like nitric acid, for example, we could see are all nonmetals, elements connected together. But since it's a strong acid, it will ionize. So we are going to see nitrate, polyatomic NO3 ions, and then we'll see hydrogen H plus ions. So those are the strong acids. These are all considered electrolytes with the ionic compounds. And then we have in the middle here, weak electrolytes. So weak acids and weak bases. So we're going to identify the strong, and then everything else will be considered a weak acid or a weak base. They fall under the weak electrolyte category because only some ionizes. So some will ionize in this category, but not much, not nearly as much as the strong electrolytes. So that's why they have a separate category. And then anything that's a molecular compound that's not a strong acid, strong base, or weak acid, weak base. So all other molecular compounds, like glucose, or methanol, or even sucrose, table sugar, these would be non-electrolytes, would not ionize at all. So we'll review how to classify these different types of compounds. And we can see an example here in pure water, so just H2O. We don't have anything dissolved. Our light bulb will not light up here when we connect to a circuit. So we have our electrodes, we have our power source, but we're not able to light up this light bulb because it doesn't conduct electricity in the solution of just, well, we'll say a solution, but in just pure water. Then we have here a non-electrolyte, so sucrose, sugar water here. And we see the sugar being poured in, but again, this does not conduct electricity, so our light bulb is not lit. But then if we dissolve an electrolyte, such as sodium chloride, we make an electrolytic solution. So we see our salt water here, salt is pouring in, and our light bulb lights up because our solution does conduct electricity because we have sodium ions and chloride ions that can move electrons around. So that's the difference here between pure water, which has no electrolytes, a non-electrolyte solution in the middle here, and then an electrolyte solution. It will conduct electricity. And we mentioned above, strong electrolytes dissociate completely. So things like strong acids, strong bases, and then the ionic salts. And then we saw weak electrolytes only dissociate partially when dissolved in water. So weak acids, weak bases will be in the middle of our table above, but they would still weakly conduct electricity. So we would see our light bulb light up just a tiny bit. So let's see in this sample exercise 1 here, if we can draw diagrams that would represent aqueous solutions of either magnesium chloride, or rather we're going to determine which of these salts is represented in this diagram. So let's see what would happen if I dissolved these salts in water. So magnesium chloride, we would get 1 magnesium 2 plus ion, and then I'm going to get 2 Cl negative ions. So this is MgCl2. And when that ionizes, this is what I get. This is what my dissociation would reveal. Then I have here KCl. So say I ionize that, I'm going to get potassium ions and chloride ions. And then last we get from K2SO4, so potassium sulfate, I will get 2 K plus ions now, and then 1 SO4, 2 negative. So what I see over here in this image are that I have 2 positive plus 1 ions for every 1 negative 2. So we can go through and we can confirm that I have 2 of those. And then down here I see a third, and then I have 4 of this 2-to-1 ratio. So what I see is that this must be potassium sulfate because I see that ratio here in this ionic compound. So we'll continue with the next section on reactions in aqueous solution in the next video.